In 7.4, we're looking at adding and subtracting rational expressions. And it's quite a bit different than the multiplication and division. The multiplication, you just, go straight across. You multiply numerator and numerator and denominator. But in order to add and subtract rational expressions, they have to have the same denominator. On number 1, this works out quite well because they both have a denominator of 10. So all I need to do is say 7 minus 2. I keep the original numerators the same. We come up with 5 over 10. Once you perform your addition or subtraction, you do want to simplify if possible. And this simplifies into 1/2. On number 2, we have the same denominator in both of these rational expressions. So that means our common denominator is a minus 4. So all I need to do is say each numerator stays the same and say 3a minus a plus 8. The only thing that you need to be careful with is distributing that negative sign. So if I'm basically saying 3a minus 8 all over a minus 4, which will give us 2a minus 8 over a minus 4. The subtraction has been completed. I just need to make sure that it's simplified. So whenever we're dealing with these polynomials, I want to make sure every polynomial is factored. Once I perform the addition or subtraction, make sure every polynomial is completely factored. And I can pull a GCF of a 2 out up top and be left with a minus 4. And the bottom does not factor. But now I can cancel these a minus 4s to just get an answer of 2. Number 3, super similar to the last two, except this is addition this time. They do have the same denominator, so that's what we're going to make it be. And the numerators do not change at all because they already had that same denominator of c plus 5. Now, once I do perform this, addition and combine like terms, if there are any, I want to make sure that my result that it's simplified. So I need to, if anything factor it. Well, I can pull out a 4 from the top and be left with c plus 5 all over c plus 5. And this factor of c plus 5 in the top and bottom cancels just to leave us with 4. So now on problem number 4, we're dealing with, again, another very similar problem. The denominator is already the same. So that makes it easy on us. The numerators will stay the same since they both had that denominator of d minus 1. We end up with this d squared minus 8d plus 7. And you just got to be careful. You distribute that negative. So the 8d became negative. And what was a negative 7, since it was minus a negative 7, it became plus right here. So just to make sure our answer is fully factored so that if something can cancel, we will see it. Factors of 7, of a positive 7, that add to give us negative 8. Well, if your factors are giving you a positive number, they have to be the same sign. Since they're adding to give you a negative 8, they need to both be negative. So d minus 1 and d minus 7, they multiply to give me positive 7. They add to give me negative 8. It always makes me feel good when I'm factoring it and something ends up canceling out. It makes me feel like I factored correct. D minus 7. On number 5, both of these expressions have the same denominator. So we will leave it as c minus 6, and the numerators do not change. Again, because they had the same denominator. So c squared minus 36 all over c minus 6. Well, c squared minus 36 is a difference of squares. That's c plus 6, c minus 6 all over c minus 6. That makes me feel good about my factoring because I had some cancellation. And we get an answer of c plus 6. On number 6, we're still dealing with the same denominator. So make one fraction, put that denominator as your common denominator, and just perform the operation in the top. So 4 plus negative 3x, which comes out to be 4 minus 3x. And I'm going to try to factor the trinomial in the bottom because I know it probably is going to end up doing that. Now, this 4 minus 3x right here does not factor. But I can say what multiplies to give me negative 24, but adds to give me positive 2. If you're multiplying to get a negative, your signs are different. If you're adding to get a positive, your larger number will be positive and the smaller negative. So what I'm going to do, let's see, 6 and 4, 6 would be positive, 4 would be negative. I'm going to rewrite this as plus 6x minus 4x minus 8, and I'm going to group it and take out a 3x and be left with x plus 2. Here are leading coefficients negative. I'm going to take out a negative. I'm also going to take out a 4, and I would be left with x plus 2. So x plus 2 and 3x minus 4. When you take out that x plus 2, you're left with 3x minus 4. So x plus 2, 3x minus 4. Well, now that we're looking at this, I want to go ahead and cancel the 4, negative 3x, and the 3, negative 4x. But notice they're opposites. The 4 is positive here and negative there. The 3 is negative here and positive here. So if I factor out a negative 1 in the top, I'd be left with a negative 4 and a positive 3x. And that is the same as 3x minus 4. I do realize they're in a different order, but the 4 is negative and the 3 is positive in both. So they cancel to leave us with negative 1 over x plus 2, which I prefer to write that as negative 1 divided by x plus 2 with that negative out front. So when we are adding and subtracting rational expressions that do not have the same denominator, we all of a sudden really get to practice what we learned in 7.3, and that is building an LCD and then rewriting each expression so that it's equivalent to a fraction with the LCD as its denominator. So on number 7, notice that a squared b to the 4th, that's not the same as a to the 4th b cubed. So we have to build us an LCD. So we write the different factors that we see. We see an a and we see a b. Now, if this wasn't completely factored already, the denominator, we would want to factor it first, but it is completely factored already. Anyway, now we want to assign each factor the highest power in which it appears in any of the denominators. Well, a, we have a power of 2, and we have a power of 4, so I'm going to give it the 4. And b, we have a power of 4, and we have a power of 3, so I'm going to give it the 4. Now I need to rewrite each expression so that its denominator is the LCD, and is equivalent to the original expression. So on the one in the top, I'm saying, what can I do to a squared b to the fourth? What can I multiply that by to make it equal to a to the fourth, b to the fourth? Well, we already have a b to the fourth, so I don't need to multiply it by any b's. But here we have an a squared, here we have an a to the fourth. So if I multiplied it by a squared, then a squared times a squared is a to the fourth, and then we have the b to the fourth. So what you do to the top, you must do, what you do to the bottom, you must do to the top to be fair. And our new expression would be 4a squared. Now, with the expression in the bottom, you have an a to the fourth and a b cubed. And what can we multiply a to the fourth b cubed by to make it equal a to the fourth b to the fourth? All you need to do is multiply it by b. So what you do to the bottom, you must do to the top, and we get 2b as our equivalent expression there. So now that we have the two equivalent expressions, we can rewrite the original to say, instead of 4 over a squared b squared, we can say 4a squared a to the fourth b to the fourth plus, instead of 2a to the fourth b cubed, we will have 2b over a to the fourth b to the fourth. And now, since we have the same denominator, we can write that as 4a squared plus 2b. Now, we want to make sure it's factored so that we know nothing will cancel, or we will see what could possibly cancel. We can factor out a 2 and be left with 2a squared plus b. Denominator doesn't factor, and this would be our final answer because nothing repeats in that top and bottom. On number 8, we need to build that LCD. So you want to make sure those denominators are factored. We can pull out a 5 and be left with t plus 2. And over here, we're already completely factored. So our LCD, let's write down all the different factors that we see. We see a factor of 5. We see a factor of t plus 2, and that's the only factors we see, okay? And you then assign each factor the highest power in which it appears, and they both only appear once at most in each denominator. So now we want to rewrite each expression so that it has a denominator of the LCD. Well, 4 over 5t plus 10, again, we factored that into 5 times t plus 2. You will notice that is the LCD. So nothing needs to change with the 4 in the numerator, okay? But now if you look right here, t plus 2, I'm wanting that to be 5 times t plus 2. So what's it missing? What's t plus 2 missing? It's missing a 5. So t plus 2 gets multiplied by 5, and what you do to the bottom, you must do to the top. So that comes out to be 30 over 5 times t plus 2. And now that we have the same denominator, we will add the numerators to get 34 over 5 times t plus 2. Everything is completely factored and nothing cancels, so that's our final answer. Looking at number 9, these denominators are completely factored. And our LCD, look, let's see, we have a factor of y minus 8. And we have a factor of y. And each of those factors only appears at most once. And so now let's write our equivalent fractions. So they have the LCD as their denominator. So now I'm wanting, again, these denominators to be the LCD. Y minus 8 needs to say y minus 8 times y. So what's it missing? It's missing a factor of y. So I'm going to multiply that by y over y. Now I'm looking at the y right here, and I need it to say y minus 8 times y. So you're going to multiply it by y minus 8 over y minus 8. When I multiply these denominators out, they will end up being what the LCD was. So I just went ahead and put that there. I'm going to make this one big fraction. Y times y is y squared plus 4y minus 32. And so now we have y squared plus 4y minus 32 all over y times y minus 8. Now I've performed the addition. I just want to make sure that we don't have something that factors, or I just want to check to see if it factors. Factors of negative 32, that would give me 4. You could say y plus 8 and y minus 4 all over y times y minus 8. And we're going to have to leave it just like this, because I know I'm really wanting this y plus 8 and the y minus 8 to cancel. But even if I factor out a negative 1, they're not opposites, so they wouldn't cancel, because right here the y's are the same sign, but the 8's are different. So both things would have to be opposite in order for me to pull out a negative 1 and cancel. On number 10, let's start by just making sure that these denominators are factored. I can pull out an m, a GCF of m, and be left with m minus 4 right here. And right here, I can pull out a 2 and be left with m minus 4. So for that LCD, let's write down all the different factors that we see. I see a factor of m. I see a factor of m minus 4. I see a factor of 2. So we're going to rewrite each expression so that our denominators match the LCD. The m times m minus 4 is missing. M minus 4 times 2 is missing a 2. So multiply it by 2 over 2. And the 2 times m minus 4 is missing m minus 4, 2. It's missing an m. So multiply it by m over m. And we'll go ahead and make this one fraction. In the top, we get 48 for the first And over here we get negative 3m squared. So now, which that's just 48 minus 3m squared. You can't combine any like terms right there. But I do need to look and make sure everything is factored. The denominator, the LCD, is completely factored still. In the numerator, there's a GCF of 3. So if you pull out a 3 from 48, you're left with 16 minus m squared all over m times m minus 4 times 2. Well, 16 minus m squared is a difference of squares. Take the square root of both and add them and subtract them. And let's see what could possibly cancel. I'm looking really hard at this m minus 4 and thinking, okay, it's not opposite of 4 plus m because the m's are the same sign, but the 4's are not. They have to both be different signs. Let's look at the 4 minus m. That's a positive 4. This is a negative. This is a negative m. That's a positive m. So if you pull out a negative from just one of them, let's just say this one right here, that would be negative 4 plus m, which is the same thing as this, negative 4 positive m, negative 4 positive m. So that would then cancel, and you would be left with the negative and a 3 and a 4 plus m in the top and a 2m in the bottom. On number 11, we're again making sure these denominators are completely factored first. Factors of 6 that add to give me 5 are x plus 2, x plus 3. Factors of 12 that add to give me 7, x plus 3, x plus 4. So let's build that LCD. We're going to list out all the different factors that we see. So I see a factor of an x plus 2. I see a factor of x plus 3. I see another factor of x plus 3 right here, but I've already written it down. And I see a factor of x plus 4. So now let's make each expression have a denominator that is the LCD, but be equivalent to the first expression. So what is the denominator of x plus 2 times x plus 3 missing in order to look like the LCD? X plus 2, x plus 3, x plus 4, x plus 2, x plus 3. It's missing a factor of x plus 4. And what's the x plus 3 times x plus 4 missing? It's missing a factor of x plus 2. So now let's write it as one fraction. And we can again write it as one fraction because both denominators are the same. They are the LCD now. So I have 3x plus 12 plus 3x plus 6, which if we combine like terms, really I didn't need these parentheses, but if this were subtraction, I like to put them there because if this were a subtraction problem, that would remind me that I need to give that negative to both of those. But anyway, when we're combining like terms in the top, we get 6x plus 18 all over that LCD. And we have performed the addition, but I need to just make sure and double check our factoring to see if it's fully factored, and it's not. I can pull out a 6 from the top and be left with x plus 3. And when you put that over the LCD, the x plus 3's cancel to leave you with 6 over x plus 2 times x plus 4. So in number 12, again, we're starting by factoring these denominators. And factors of 2 that add to give you 3 are p plus 2 and p plus 1. And the p squared minus 4 right there that I scratched out is a difference of squares. So that could factor into p plus 2 times p minus 2. So that when you're writing the LCD and you list all of the different factors that we see p plus 2 and a p plus 1. And then when we're looking over here, we see a p plus 2 and a p minus 2. Well, I've already written down p plus 2. So all I need to do is write down the p minus 2. And you are always supposed to go back and see, okay, am I assigning what's the highest number of times, what's the highest power that each factor appears in any individual denominator, and it's all appearing only once in a denominator. So that is our LCD. So now to make both of those expressions have a denominator that is the same as the LCD, let's see what we need to do. P plus 2, p plus 1 is missing a factor of p minus 2. So multiply that by the top and bottom. And then p plus 2, p minus 2, p plus 2, p minus 2 is missing a factor of p plus 1. So at this point, I usually like to write the fraction since they have the same denominator, which is the LCD. I usually like to write it as one big fraction. And I can do that, but as I'm doing that, I usually like to just multiply out the numerators. Well, this time we have binomials times a binomial. It's not just simply distributing a constant to a polynomial. This is a binomial times a binomial. So what I have to do is FOIL it out. I have to say p times p is p squared. I have to say p times negative 2 is negative 2p. So now we need to say negative 3 times p is negative 3p. And negative 3 times negative 2 is positive 6, which adds to give you p squared minus 5p plus 6 when you're combining these like terms right here. On this, we need to distribute as well because we have two binomials. So we get p squared, p times 1 is p, negative 1 times p is negative p, negative 1 times positive 1 is negative 1. But again, we have like terms, p minus p, that just completely cancels to give us p squared minus 1. So now I can, in my numerator, call this p squared minus 5p plus 6 plus p squared minus 1. And when I combine like terms, I get 2p squared minus 5p, and 6 and negative 1 give me positive 5 all over that LCD. And you do want to try to, again, make sure that everything's factored. The denominator is already factored. But that numerator, 2p squared minus 5p plus 5, you would have to find two things that would multiply to give you 10 and add to give you negative 5. And those two things just don't exist. So that means the numerator is prime. So it doesn't factor, and since it's in fully factored form, and nothing repeats, well, nothing cancels. So this is our answer. So for this whole lesson, our expressions, we've only had 2 of them, but you can do more than 2. So let's just start by building that LCD. We have to have the same denominator again to subtract and add. And to build that LCD, I need to first make sure everything's factored. C plus 2 is factored. C is factored. C squared minus 4, that's a difference of squares. So we could call that C plus 2 times C minus 2. So for this LCD, let's write down all the different factors we see. We see a C plus 2. So write it down, copy paste. We see a factor of C. We then see a factor of C plus 2, but I've already written it down, and C minus 2, and that's not up there yet. So I need to rewrite all 3 of these expressions so that the denominators look like the LCD. So the first denominator to the far left, the C plus 2, what's it missing? It's missing factors of C and C minus 2. What you do to the bottom, you must do the top. Okay, right here, the factor of C. What's it missing? It's missing quite a bit. It's missing a C plus 2 and a C minus 2. And to finish it off, C plus 2, C minus 2, what's it missing? A factor of C. So, writing it all as one fraction, you will notice that we will have, the denominator will be the LCD, and we will have something minus something plus something. So that's I kind of set up a template for myself. Right here, we have 2C times C minus 2. So basically, you're distributing a 2C minus 2, which gives you 2C squared minus 4C. Right here, I have to, before I distribute a 3, I think I'm going to distribute to FOIL the 2 binomials. So that's a C squared, then C times negative 2 is negative 2C. Now 2 times C is 2C, and 2 times negative 2 is negative 4. That cancels. It gives me C squared minus 4, which you then need to distribute a 3 to. So 3C squared minus 12. And now, basically, just picture this as being C times C plus 10. It's the same thing, right? And so now we kind of see it easier to distribute that C to the binomial behind it. So that's just C squared plus 10C. So what I've done at this point is basically clear the parentheses. The 2C squared minus 4C didn't necessarily need them at all. So I left that as it was, but I had to distribute a negative to the 3C squared and the negative 12 C, to the negative 12 to get negative 3C squared and a positive 12 right here. And then this just had, was positive 1, so that 10c squared plus 10c stayed the same. At this point, we can combine our like terms. We have, let's see, 2c squared and negative 3c squared and a positive c squared right here, and right here. C squared plus 2c squared is 3c squared, and 3c squared minus 3c squared completely cancels. So that's gone. And then we have a negative 4c and a positive 10c. So that would give us 6c. And then once you combine those, you're just left with 12. So at this point, our operations of subtraction and addition have been completed. I just need to make sure everything's factored. And as always, if you leave that LCD alone, it's fully factored. The numerator, we can pull out 6 and be left with c plus 2. So your factor of c plus 2 in the denominator will cancel with the factor of c plus 2 in the numerator to leave you with 6 over c times c minus 2.